quick review of what we did last time. Last time we took a look at binomial variables. We learned how to check the conditions. We learned how to calculate probabilities. And we took a look at the calculator. What we're going to talk about today is mean and standard deviation. And then we are also going to look at what is called a geometric variable. On the calculator, we did a few quick things. On the formula sheet, I told you, but we didn't really talk about a binomial distribution. We have this formula. I think I told you that you don't need to use it, but you need to be able to recognize it. Here's the formula for mean and standard deviation. And then what we're also going to talk about today is geometric. And again, here are the formulas for that. So in the notes, we're going to continue with binomial. Mostly it's going to be calculator stuff. And then we'll take a look at geometric. I need to find this page, please. This page. Okay, starting with how do we calculate binomial probabilities on the calculator? There are two. When you go to second distribution, you're going to see binom PDF and you're going to see binom CDF. PDF calculates x is equal to some number. CDF, which is cumulative, does x is less than or equal to some number. In both cases, the calculator wants to know how many trials are there, what is the probability of success, and what is the x value. So we're going to take a look at a few quick examples. So the first example, if we are flipping a coin 50 times and counting the number of heads. Before we look at the calculator, I want to talk about why is this binomial. So what should be going through your head is a binomial distribution. We are looking for a certain number of successes in n trials. So in this case, our success is a head, failure is a tail, and we're flipping 50 times. So then we ask ourselves, are all four conditions met? B, is this a binary variable? That just means is there success or failure? Yes, heads, tails. Are the flips independent? So whatever I get on the first coin flip, is that unrelated to the next coin flip? N is for fixed number of trials, which yes, that's the case. We have 50 trials. And then S is the probability of success the same. You do not need to write this when you are doing a binomial question. This is what you should be thinking through. So this is what you should be thinking through. Yes, all four of those are met. Yes, this is binomial. What you do need to write is you need to write x is binomial. N is the 50 flips. P, the probability of success is 1/2. Now, a lot of you don't remember to use this notation. That's fine. I don't care if you put an equal sign. Doesn't matter. As long as you write binomial, you have the N labeled and the P labeled. We're going to calculate those three probabilities. They are done differently on the calculator. For x equals 25, because that is a single probability, you would do binom PDF. You're going to tell the calculator n is 50, probability of success is 1/2, and my x is 25. Can you do that right now, please? So go to second distribution on your calculator. Those are the three numbers that you need to put in. As I reminded some of you, your calculator will ask you what are n, p, and x. For others of you, you just put those numbers in and separate them by commas. And we should get about 0.112. Is that what we got? Yeah? if you were using the formula, which again, I said you don't need to know the formula, you need to be able to recognize it though. The formula would show you something like this. 50, choose 25, 1/2 to the 25th, 1 minus 1/2 to the 25th. So just to talk about, this is our successes. So these are our 25 heads. These are our 25 tails. What did we say that accounted for? So we said it's not a fraction, but what does that number mean? Kyle?
Number of trials versus successes.
Why do we need it, I guess? That's my question. But yes, it's number of trials, number of successes. Why do we need that part in the calculation? Why can't we just do 0.5 to the 25th and 0.5 to the 25th? Maybe like scroll back in your notes. Maybe don't just stare at me. Because we definitely talked about it. If you look on the previous page, we took a look at the probability that x equals 1, probability that x equals 2, and they ended up with some extra number we had to multiply by. Why?
Different ways to get there.
Yeah. Do you remember talking about how out of the 50 flips, those 25 heads can happen multiple different ways? Any of that sound familiar? That's what this is for. Okay, so then next one, probability that x is less than or equal to 18. On your calculator, that is a CDF. So you'll do CDF. N is still 50, P is still 1/2. This time x is 18. When you do CDF, the calculator is going to calculate 18, 17 all the way down to 0. So do that real quick and make sure that you get about 0.032. Are we getting 0.032? Okay. So then, last one. What happens if it's greater than? So if we're doing greater than 30, this would be the probability that x equals 31, 32, all the way up to 50. The calculator cannot do greater than. It can do less than or equal to, though. So we're going to calculate the complement instead. So 31 up to 50. So what we don't care about then is less than or equal to 30. So this would calculate 0, 1, 2, all the way up to 30. If we subtract that from 1, that will give us what we're looking for. So can you calculate that right now, please? Calculate x is less than or equal to 30, so that's a CDF. But then subtract from 1 because it's the complement. I get 0.059 when I do that. You guys get the same thing? Okay. Are we comfortable with the calculator use? Yeah. Okay. Is it okay to use Binom PDF and Binom CDF commands on the AP exam? No. No. Instead, what you should do is what I've been saying, write binomial n equals something, p equals something. And then you're going to write probability notation. For example, you could do probability that x is greater than 30. If you don't like that, you could do x equals 31 all the way up to 50. That's what you should be showing, though. That is proper notation. Kind of like I said, don't show normal CDF on the AP test, right? Write normal, write mean and standard deviation, or show the figure. Okay. We're going to have a quick real talk section right here. I said don't write normal CDF on the AP test. But I said if you do, write normal CDF, what do you have to do? Okay, that's exactly what I was looking for. So you can show binom PDF and CDF if you label your numbers. So exactly the way that I did. So if you're gonna write binom PDF or binom CDF, label the numbers. I would prefer you don't, but if you're going to, label the numbers.
So if you do that, then do you not have to do everything in blue?
Technically, yes. I don't love that, but yes. Okay, questions? Okay, we are going to do 2 more things for binomial, and then we'll take a break before geometric. Calculating mean and standard deviation of a binomial distribution. First of all, are these on the formula sheet? Yes, I already showed you that on the front page. The mean is the square root of np 1 minus p. Again, that's on the formula sheet. I totally just lied to you. That is standard deviation. Mean is just n times p. Last thing we're going to do is we are going to calculate and interpret mean and standard deviation for the roulette problem. Let x be the number of the next 10 spins of a roulette wheel that land on black. And the probability of black is 18 out of 38. Calculate and interpret the mean and standard deviation. Okay, so I think I told you guys when we did binomial before, the first day of it, that the biggest mistake is people don't recognize a binomial distribution. So I'm going to keep talking about what sets off to me that this might be binomial. As soon as I see 10 spins, that's a fixed n. That's what tells me that this might be binomial. It's not necessarily going to be, but that's what tells me it might be. So then I ask myself, am I looking for a certain number of successes? Yes, I'm looking for how many black there are out of the 10. So then I would do the bins in my head. Okay, so in this case, this is a binomial distribution. Our n is the 10 spins. Our p is the probability of success, which is 18 out of 38. Our mean then is n times p, which is about 4.74. Standard deviation is about the square root of 10, 18 out of 38, 1 minus 18 out of 38, which is about 1.58. What is really important to me is how we interpret these. So that's the last thing we'll do, and then we'll take a break. The interpreting is in the long run. This is where we have to be careful, though. The long run in this case does not mean spinning the wheel multiple times. One set is spinning the wheel 10 times. So we would spin the wheel 10 times, multiple times. Here's the way I would write this. If we were to spin the roulette wheel 10 times, I was going to say many times, but that doesn't sound right. You people that are good at English, what sounds better? Over and over? Love that. Thank you. Over and over. The average number of times the wheel would land on black is 4.74.
Is the like standard deviation formula an approximation and the mean too, or?
No. No, so I guess really it should be
Okay.
that, and then I round it, yes. Good question. Okay, and then standard deviation. Again, if we were to spin the wheel 10 times over and over, the number of times the wheel would land on black would typically deviate from the mean by 1.58. The from the mean is important. That's what you all tended to leave off the last time I looked at your interpretations for standard deviation. That is the binomial distribution. Questions, comments? Okay, that is all things binomial. And remember, binomial is just a special discrete distribution. Next page talks about a normal approximation. I decided that wasn't important for us, so we're not going to do that. You're going to go all the way to the bottom, and we're just going to talk about geometric distributions. Conditions for a geometric distribution. We already talked about conditions for binomial. For a binomial, it's the bins. For geometric, it's still the B, still the I, S. No N. B still stands for binary. I is still independent. S is still the probability of success is the same. So one of the main differences is a geometric distribution does not have a fixed number of trials. So let's talk about what is a geometric variable. Geometric random variable is we are going until we hit the first success. So binomial, there's a fixed number of trials. We're looking at a certain number of successes. Geometric, we're just going to go until we get the first success. So if you remember, for binomial, possible values, we could have 0 successes, 1 all the way up to n successes. For geometric, on the other hand, if we are going until we get our first success, we have to have at least 1 trial. So geometric, there cannot be x equals 0. It's 1, 2, so on and so forth, all the way up to infinity. There's no upper limit. Okay, parameters. Binomial is n and p. There's no fixed number of trials, so the only parameter for geometric is p, the probability of success. So we are going to do this one example, that's the rest of the page, and that's it for the notes. In the board game Monopoly, one way to get out of jail is to roll doubles. Suppose that a player has to stay in jail until he or she rolls doubles. The probability of rolling doubles is 1 out of 6. So first we need to recognize, why is this geometric? I'm going to say this is a geometric setting. Because, firstly, just context-wise, the player is rolling until they get doubles, which is a success. So that's the context-wise when I'm reading it, why I think, yeah, this might be geometric rather. So now that we think it might be geometric, we want to check, are the three conditions true? Is this binary? Yes, it is. Either we roll doubles or we don't roll doubles. The rolls are independent. So I roll my 2 die, that's independent of the next time I roll. And then the probability of success every time I roll is 1 out of 6. So then if we define our random variable, we're going to say x is the number of rolls needed to get doubles. How many times I have to roll to get doubles. Okay, this is something that a lot of times people don't understand when it says state its distribution. What that means is saying that x is geometric and our probability of success is 1 out of 6. So that's just the type of distribution. Could be geometric, could be binomial, could be normal. Okay, what is the probability that it takes exactly 1 roll to get out of jail? 1 out of 6. Exactly 2 rolls. So 2 rolls would mean I didn't roll doubles, then I did. So that is about 0.139. Three rolls. I didn't roll doubles, I didn't roll doubles, then I did. That's about 0.116. What about the probability of 100 rolls? How would I figure out the likelihood that it takes me 100 rolls to get out of jail?
5/6 to the 99 times 1 out of 6.
Okay, so I didn't get doubles 99 times, then I did.
It's a very small number.
Yeah, about 0. Okay, big difference here is there's only one way these things could happen. So we don't have to consider where this success falls. It's always going to be the last one. So in general, how do we calculate geometric probabilities? This is on the formula sheet. If we do the probability of x being equal to some number, we have 1 success. So that's that 1/6. 1 minus p is all of our failures. So that would be to the n minus 1. So this is my 1 success. Everything else is a failure. Is this on the formula sheet? Yes, it is. Along with mean and standard deviation. The mean is just 1 over p. Standard deviation is the square root of 1 minus p over p. And then last thing to tell you. So again, you don't need to use this formula. You just have to be able to recognize it. Your calculator does have geometric PDF and it has geometric CDF. Still under second distribution. Still under second distribution. PDF still does x equals some number. CDF still does x is less than or equal to some number. For binomial, you put in n, p, and x. Geometric doesn't have an n, so you're just putting in p and x. So I don't expect you to use the formula. I expect you to use proper notation. So this variable is geometric, this is p, and then use your calculator. How do we feel about binomial and geometric? I will say just two last things. The most common issue with these two is firstly that people do not recognize the binomial and geometric, and secondly that they do not write the correct work. So I think I told you guys that I grade AP tests, and I graded the binomial question last year, and part B was binomial and part C was binomial. Students lost credit in both parts each time they didn't say binomial, which is a pretty harsh thing if you forget it twice.
So if you say it in like the first part, it doesn't like translate to the next part?
They didn't last year, no. Normally I would say, yeah, of course it carries, but for whatever reason, they didn't allow that.